I'm going to show you how to pull up the ElevatorSim example in WPILib. So first you want to do Control-Shift-P to create a new project. Project type is going to be an example, project language, Java, and then type elevator to get ElevatorSimulation. Our folder, just going to put it in here. Project name, ElevatorSim works. Yeah, we'll create a new folder, type in your team number, and this is important, enable desktop support. It is needed for simulation, so you can't leave this unchecked or it won't work. So hit generate project. It's going to say it's generated successfully. Yes, let's open it in the current window. Yeah, I trust the authors. So we'll wait for this to build for a moment here. Alright, it has finished opening. We can come in here and see what we've got. So we've got 4 files: elevator, constants, main, and robot. So main is what you'd expect, nothing much here. Robot has some stuff in it that would be interesting. And the bulk of the interesting code is inside of elevator. So first, let's look at what our inputs and outputs are. If you go to robot, you'll see that we have a joystick, and from the joystick, if you just do a right click on here, find all references, the only thing that is used from the joystick is we see whether or not the trigger is pressed, and it's just in teleop periodic. So we know we're going to have to go into teleop mode, and we're going to have to press the trigger to see what happens. And what it does is when you are holding the trigger down, it sets the set point height of the elevator, or the goal height of the elevator, to be 0.75 meters. And when you let it go, it drops the goal height to 0. Simple enough. The question is, how do we look at what this simulation is doing? You know, what's it doing with the elevator? And that's a little bit harder to find out. But I'll tell you, if you go into elevator, they create this set of objects here that is a visualization that appears on the simulator window. So you can pull up this visualization, and inside of there is this, this ligament, mechanism ligament, and they set the length of it to, well, they set it here, but it doesn't really matter. They set it every cycle to the distance that the encoder sees, and the distance that the encoder sees is the height of the elevator at the moment. So that's what we're looking for. We're looking for the length of this mechanism that is called elevator inside of elevator root. So in order to see that, we're going to have to pop open the simulator. Simulate robot code. Alright, so we got the simulator up. So you'll notice there's not a lot going on here. Nothing immediately comes up that shows you what you should look for. If you come up to Network Tables, Smart Dashboard, ElevatorSim, this is what they intend for you to use to look at it, but this doesn't show anything interesting right now. The first step is to get a keyboard set up as a joystick. You could use an actual joystick. If you had one plugged in, it would appear here, but I don't. I'm going to use a keyboard. Right click on keyboard 0, and the trigger is button 1. So button 1, Z, that'll work. So, alright. Now, in order to tell it that joystick 0 is keyboard 0, I'm going to drag keyboard 0 over to joystick 0. And now if I hit the Z key, you'll see that it shows button 1 illuminating. Alright, so if I put this in teleop mode, and I press Z, you will see the tiniest little orange bar appear at the bottom here. You might go, is that working? Is that what it's supposed to do? Well, you can trace down where this goes. So if you go into Network Tables window, Smart Dashboard, ElevatorSim, Elevator Route Elevator, you will find this value that's bouncing around here, this length variable. You hold down Z, you'll see it goes up to almost 0.75, which makes sense. That's where the thing is, that's where the elevator is supposed to go. If you let go, it goes back down to 0. So that works well. But again, it's not very visible. This little rectangle is tiny. So instead, we can make a plot, new plot window, add a plot, and drag this length variable into there. And now if I hold down the Z key, you'll see much more interesting graph here. So I'm holding it down, I let go, and it ramps back down to 0. So that's cool, but we don't have any other information about what's going on, and it would be nice to have some more of that information. We have this length, and that's it. So I'm going to close out of the simulator, come back here. Let's go into Elevator, and let's just put some more data on the Smart Dashboard. Right now, the only thing being put is that ElevatorSim, and the piece that's being updated is this set length of this rectangle from the encoder. But we can do much better. In update telemetry, let's put another couple of Smart Dashboard outputs. So Smart Dashboard dot put number. Let's go elevator position would be a good one to have, and that one we can get from m_encoder dot get distance. Go Smart Dashboard dot put number. We'll get the goal, that elevator goal that we had set before. That was, remember, that was called from main, sorry, from robot. Under elevator reach goal, they gave a set point. So that goal comes in here, reach goal. It goes into the controller, so we can pull the goal out of the controller. So m_controller dot get goal, and this isn't going to work. It's saying, well, goal is not a number, because goal is a velocity and a position. So dot, oops, get goal dot position. And then finally, Smart Dashboard dot put number elevator set point. You'll wonder why goal and set point are something different. Well, m_controller dot get set point. It's also going to be dot position. And you'll be able to see the difference shortly in here. So with that, we can save, Control-Shift-P, simulate robot code, sim GUI. There we go. Let's take this length out of here, and let's bring in our position, our set point, and our goal. There we go, we got 3 colors for this. We'll enable teleop and hit the Z key. Now something much more interesting happened here. So I'm going to pause this for a moment so we can see. So you can see that goal immediately jumped up when we pressed down the Z key. Went up to the top here and it stayed. We can see that set point made this really fancy shape here, and the elevator position followed the set point all the way up. So set point was rate limited. It did not jump immediately up to the top. And that comes from the profile generator. So if I run this again, you'll see it come back down the same way. Let's see if we can get some more out of the profile generator here. Smart dashboard dot put number elevator velocity. Let's make it elevator goal velocity. Value m underscore controller dot get, well, set point velocity. Get set point dot velocity. There we go. Now, let's add another plot window. And we'll stick the set point velocity down here. And now if I enable, we can't see what's going on. Y-axis. Let's auto fit. There we go. Now whenever I hold down Z, you'll see the velocity goes up and then back down. So it's always a positive velocity here. But once we reach the set point, the commanded velocity is 0 again. So this is where the trapezoid comes into this. Unfortunately, we can't actually see the full trapezoid because it gets to the goal before it hits the max speed. So, just as a way to look at that, a way to get this trapezoid to occur, here is the profile. Here's the trapezoid profile that we're using. And the max velocity is set to 2.45, I think it's meters per second. But if we change this down to, like 1 meter per second, and we rerun the simulation, we should get a chance to see it cap the velocity. There we go. Nice trapezoidal profile on the way down too.